Okay, let's start the 5G core track for this 2021 fall workshop. Let's get started with Tin. And you can share your screen, Tin.
Okay, let me share my screen. So can you see my screen now, Rafael?
Yeah, we can see your screen.
Okay. So hello, good morning, good afternoon, and good evening also. My name is Tiến Thị Nguyễn. I'm leading the 5G core network activity at the Eurocom and OpenAirInterface Software Alliance. So it's my pleasure to be here today with our core network team to welcome you to the core network section. So in this section, we will go through together the 3 different labs and presentation in which we will discover different flavor of the OAI core network and its main features. Okay. First, just a few words about our project. OAI 5G Core Network project is one of the 4 projects under OAI umbrella together with RAN, CI/CD, and Mosaic 5G. And our objective is to develop a fully 3GPP compatible 5G core network stack for the OAI community. And so I would like to thank our sponsor for their support and also our contribution for the development of the 5G core. So before going to the lab, let me remind the current status of our 5G core network. Currently, we have a solid and functional 5G core network with basic functionality which are validated with the different methods. For example, with a professional tester, with OAI G-Node B, with the different commercial and open source G-Node B as well. And of course, with also different UE, including OAI UE, some course UE and simulated UE. For the deployment, we have 2 different options to deploy OAI core 5G core. The simple one is to use AMF, SMF, NIF, and UPF, which we call a minimalist. The basic option use 3 more network functions, UDM, AUSF, and UDR. For now, mainly for the UE authentication and procedures. So in the minimalist deployment, to make it work, the AMF use an internal mechanism for authentication and authorization to mimic the functionality of UDM, AUS, SS, and UDR. And the SSF, the SMF use a local and predefined subscription information instead of retrieving this information from the UDM. And our colleague Saga will explain in more detail this option in a couple of minutes. And for the user plane, we have 3 different flavors. SP Gateway U from 4G, which is a simple implementation, easy to deploy, but with a limited performance. The second flavor, VPP traveling with DPDK support to achieve a better performance. And finally, production grade UPF from Kalum. Again, we can find more detailed information about the user plane function from lab 2 with Rohan. And we also provide 3 possibilities to deploy our core network with a traditional approach, Docker Compose and Helm chart. We will show you how to deploy with the Docker Compose during the lab today. For the roadmap, let me go very quickly through the main task, and you can find detailed information in our 5G core network project website. For the next release at the end of 2021 and beginning of 2022, our main task is to provide a minimal support for private 5G core network, which become an important use case for us. And we also plan to release HTTP version 2 support for the whole core network components and release an SSF for network slicing. And for the first quarter of 2022, several additional features will be added. For example, to fully support network slicing scenario with multiple AMF, support of multiple UPF in the same data path, and is for the private 5G network and for traffic steering scenario. Then for the second quarter of 2022 onward, we want to add some more advanced features such as IPv6 support, redundant transmission support for ultra reliable low latency communication, branching point, and uplink classifier features for mobility support. And we also plan to add several more network entities such as UDSF and WDAF. So for the core network section, here the agenda. And without the further delay, let's go to the lab one with our colleague Saga. And thank you all for the participation and enjoy the lab section. So with that, I stop sharing and hand over to Saga.
Yeah, hello everyone. I'll start sharing my screen. Yeah, I hope you can see it. Hi, I'm Sagar Arora, and I'll welcome you all for the first lab session of today. That is on how to deploy OAI 5G core network.
Your sound is a bit.
Sorry? Yeah?
Your sound is a
bit. My
weird.
sound is. My sound is weird.
A bit weird. Are you,
okay.
Are you too close or too far away from your mic?
No. Just give me a moment then.
Okay, let's go.
Yeah, is it fine? Yeah. Okay.
Yeah, let's go.
Yeah. Okay. So, guys, sorry for the sound. If you have any questions, just please ask in the chat. I'll start. So, in this lab session, what I will show you guys is about how is a common directory structure of all the OAI core network components, and then how to deploy these two different flavors of OAI core network, which Tin was talking about. And then how to configure a new user in the database and check the logs of the core network components. And then in the end, we will see that we'll do end-to-end simulation using a UE and a GNB emulator, which is known as GNB Sim. So as Tim showed you earlier, this is what we have today, what is available with all the core network components which are available. After the presentation, after this lab session, my presentation will be available. You can click on all these GitLab directories to go to the respective directory of all the network function components. If you want, you can also Google it. You can also Google OAI AMF or SMF. You will find it. And then, so for today, what we can deploy the core network using two different methods. So the first is using Helm chart. So the Helm chart method is used to deploy on a production grade Kubernetes cluster or a vanilla Kubernetes cluster. And you can also use a Docker Compose, which is quite lightweight. You can do it on your personal computer. You can deploy the OAI core network on your personal computer. I do it myself. I do the testing on my own computer. And this is for single node deployment. And so far, we have the images available for two different operating systems, but we publish only one, which is on Ubuntu 18.04 on our Docker Hub. And the Red Hat images you can build by yourself using your Docker files if you have the license for Red Hat. And in the Docker Hub, you will find two different images of our core net of every core network component. The first is the develop image, which automatically builds from our develop branch. And then the version tagged images are the one which we publish for the most stable version. So develop sometimes can be stable, like cannot be stable. And then it's so this is the directory structure of AMF, though. So what you're seeing right now is similar or is common for all, is mostly common for all the core networks. And here what you have to see is more about the location of the configuration file, which is placed in the EPC. sometimes what happens in our Helm charts or our Docker Compose, some of the variables of the core network component is not configurable. We have set it as, let's say, it's fixed in the configuration file, but it can be changed. For that, you need to change it manually by yourself in the configuration file. So now let's go ahead. I guess you all must have received an email with your user ID and private key on how to access the VM, which is also allocated to you. And after this lab, Camille will send us to the breakout rooms, and in every breakout room, there'll be one mentor. And if you have to, sorry, you can mute your mic. Yeah. So in every lab, there'll be one mentor, and if you have questions regarding the particular lab, regarding, let's say, a particular deployment, you ask your mentor. So first, what we do is that when you go in your directory of your user directory, there'll be lab 1. In lab 1, there are 2 parts. The first part is on deploying the minimalistic OAI core network. You can see the architecture which we will deploy. First, we deploy the core network. Then we deploy the emulator UE and GNB. And then after that, we do the testing. And then after that, we deploy the basic functional core network, and we do the testing of the basic functional core network. In your instruction file, you will see that there are 2 different set of instructions. First, it's sort of a quick guide, which I would recommend you should all follow rather than the elaborated one. And after this particular lab, we will send you an email with all these instructions and the Docker Compose and all the manifests, so that you can do it yourself in your personal machines. So, and at that point of time, you can also follow the elaborated instructions. So that's it from my side. If you have any questions, you can leave it in the chat.
Yeah, so last thing that you should be aware of that is that this VM will be still on for next 2 hours after the session, so you can keep working on your experiment while we are in a break ourselves. But anyway, yes, I think one answers the last question. And how do we compare core networks with Open5GS? Let's not play comparison games, okay? Okay, I think we are almost on time. In fact, we are in advance. We are almost 5 minutes in advance. Helm chart deployment and Docker Compose. Okay, so Docker Compose, you will deploy all your container on a single host, and it's easy because everything is described in one single file, as we will do in the lab. Whereas the Helm charts, you will deploy that into a cluster where there might be one or multiple workers. And so that means that your container will be deployed within these multiple workers. So that's the main difference. Helm chart is a bit more difficult to read because there is plenty of files. And especially if you want to use the 5G core as a tool for your run, yeah, it's better to use a Docker Compose than a Helm chart. It's much easier for you guys. One message. Is there any plan to support 5G Ethernet communication? Tin, that's for you.
Yeah, we want to do that because you see it's similar to the 5G LAN services. So we want to do that in the second quarter of 2022. Yeah.